So this event is organized by the network H2, and it's part of a series of webinars that are looking at different aspects of hydrogen research in the transportation sector. This week, we are looking at the challenges around multimodal transport and logistics, and are delighted to welcome two speakers from Ballard Power Systems Europe this afternoon, who will provide their own insights into this topic from a leading industrial perspective. We have asked each of our speakers to present for around 20 minutes. Once they have finished, we'll open up the mic. And so, so our next speaker is Kristina Juelsgaard. I'm sorry about the pronunciation, Kristina. She's the head of business development for Ballard Power Systems Europe. And as David said, we'll present on the marine sector. Kristina holds a master's in international technology planning and spent 20 years working in the energy industry across sectors, including energy efficiency solutions, renewable technologies, hydrogen development, with a special focus on zero emission fuel cells solutions for heavy duty motive and marine applications. She is a board member of the Danish Hydrogen Association and participates actively in the working groups of Hydrogen Europe to bring fuel cells and hydrogen technologies to the market. So over to you, Kristina.
Thank you very much, Tony, and good afternoon to you all. And let me also thank you on behalf also on David for having us here today and share with you some of our views on fuel cells, and particularly the maturity on the technology on where we are today. About 5 years ago, everyone would ask us, is it safe? Before even considering a hydrogen bus or any other vehicle, is it a safe technology? We don't get that question anymore. This perception of safety and the perception that hydrogen is a very dangerous fuel to work with has been replaced by, does it work, and does it work efficiently? And is there a positive business case? And for us, I think that's one of the biggest achievements over these last 5-10 years, that we have come to now no longer have to prove the concept, but have to validate the business case behind it. David told you a lot about our experience in hydrogen buses and also in trucks, which we have over the last 15 years collected substantive amounts of data, experience and learnings. And it's these learnings and experience and procedures that we have moved and built into our next market segment, the maritime segment, which I'm going to present some slides about. So fuel cells for marine applications. This is to a large extent built on the many years of experience from heavy duty vehicles on land that we are now taking to sea. And the main driver for this is really the fact that the shipping industry is one of the really large contributors to greenhouse gas emissions worldwide. Both on CO2, but also on other unpleasant particles of NOxes and SOxes are each year contributing to a poorer air quality, particularly around the ports and the cities near the coast, but also actually on the oceans themselves. So with hydrogen and fuel cells for marine, we are really setting out to contribute significantly to the reduction of greenhouse gases at sea. We are supported and helped and controlled a little bit by all the zero emission requirements that are now in progress to being enforced onto the marine segment, headed by the IMO, with very ambitious targets to phase or to cut emissions by 50% before 2050, and equally by the European Maritime Safety Association, the EMSA, to also achieve the same goals. Some of the front runners in this are Norway, who are even upping that ambition a bit by already going 100% zero emission in some of their World Heritage fjords already in 2026. to go entirely zero emission on all vessels going in and out of these fjords. It's certainly ambitious, 2026, that's nothing more than just a few weeks ahead of us, and everybody is struggling really hard to make this happen. We also see that a lot of other countries and regions are following, maybe not as ambitious as Norway, but certainly with very high requirements to decarbonize before 2030 and to take a careful look at what is out there and how can this be done. It is a challenging application to decarbonize. The history of marine power supply with large diesel engines, it's over 100 years old. It's a culture, it's a religion to many, and this is about to change, and such change takes time. The zero emission solutions today are mainly battery and fuel cells, and the battery electric, the pure battery electric ferries have, at least just in Denmark and Germany, also in Norway, already gained a lot of traction. They have some disadvantages, and this is then where we see the hydrogen fuel cells kick in and can sort of fill the gap where the battery electric ferries and vessels are not, don't have the required range and don't have the required autonomy and flexibility in terms of operations. So this is similar to what David said about the buses and trucks. The biggest advantage for the hydrogen fuel cells on ships is to provide a longer range, a faster fueling. It is, in addition to the benefits on the buses, on marine, we see a high need for scalability and modularity up to bigger power sizes that we have not met before when we're looking at the bus and the truck world. And then, of course, the reliability, the safety, the long lifetime, the low maintenance cost are all added features that we also stress are important in the marine segment. At Ballard, we have taken all these great knowledges from the bus and the truck world, we have put it in a box, and we have marinized it, so to speak. We have created a new design, but based on the same reliable and proven core components of the fuel cells from the heavy-duty transport industry on land. And we have designed it to meet all the safety and operational requirements in the marine segment. Our product is called FC Wave. It is a 200 kilowatt building block, which is designed for scalability to be able to line them up in parallel and together create solutions, power solutions for up to several megawatts built out of this one building block. The same advantages as was with the buses. The hydrogen is carried on board the vessel in tanks. The air, the oxygen for the fuel cells is taken from the air. The chemical reaction in the fuel cells is the same. The exhaust, being water, is the same. The heat from the fuel cells, there's quite a significant amount of heat, can also be reused on the vessel in order to provide an even higher energy utilization, energy efficiency on the vessel. The scalability from 200 up to several megawatts is one of our key features that we are very proud of. Also, for marine fuel cells, we are happy to say also the life cycle costs are lower compared to the equivalent battery solutions. Battery-only solutions, we meet the safety standards of marine requirements, which are quite strict. It's been a long learning curve to work both with the certification authorities, DNV, Lloyd's, Bureau Veritas, we have very good collaborations with, but also the flag, the national flag states and authorities have been very curious and collaborative in also learning about this new technology to agree on this new standard. We focused also on easing the integration replacing a traditionally diesel-driven combustion technology with an electric-driven propulsion solution has required a lot of new ways of thinking. We need the space for the hydrogen tanks. Hydrogen tanks take up more space than the equivalent diesel tanks, and this has created a lot of innovative and creative solutions on how to do that. When we look at the cabinet itself, it's designed as an upright standing cabinet, whereas the bus modules we saw before are lying down and typically at the back of the bus or maybe even under the bus. These cabinets are typically placed in a technical hydrogen room, similar to what would be a machine room or a battery room. All interfaces are accessible from the front. So also here we are designing it for easy maintenance, easy access for people to come and replace components and to service the technology. Connections are all located in the bottom of the system, enabling them to be installed below a false floor for easy access and easy replacement when needed. And it creates a flexible solution with several modules lined up to be able to operate them all or in cascade-wise, to keep them all operating at their optimal design point to achieve the best fuel consumption and the optimal lifetime conditions. All our systems we have delivered so far are components in a hybrid battery plus fuel cells electric hybrid power system that are controlled by a power management solution. The batteries will typically take over on all the acceleration, maneuvering, peak creating power needs, and the fuel cells will be sort of the following component, trying to charge the batteries first of all and supplying all the continuous power for more steady speed operation and providing the longer range. Together with batteries, the fuel cell electric propulsion system is a very powerful solution to drive both the propulsion system, but also the hotel load auxiliary systems on board the vessel, and can also provide heat to the vessel if needed, and in some cases even the exhaust water, so the H2O from the exhaust can be reused as a second freshwater source on vessels. In some application that also has there's an interest to reuse the water. The hydrogen storage tanks are placed typically, at the moment anyway, we are still in the early years of how to design vessels for hydrogen. For now, the authorities approve easily the hydrogen storage tanks to be approved on deck, above deck, up towards the air. And currently a lot of discussions and good work is trying to get the hydrogen storage tanks below deck integrated into the vessel. At Ballard, we have established the Marine Center of Excellence in Denmark, covering not only the European maritime activities, but actually the marine activities worldwide, both for ships, but also port equipment, heavy duty equipment and installations on sea, cold ironing installations that are catching on more and more on a global level to provide the zero emission solutions to the whole marine sector. And in Denmark, we are manufacturing these FC Wave modules, so the products themselves come out of Denmark. And here we also have conduct the training, have the spare parts supply, do the design, the customized design solutions for customers, have our consultants sitting to support every part of the wave together with our customers. The first applications that we go for here are the ferries. They are very reliable in their scheduling. We know exactly when they're sailing out and coming back, what's the route, and also the sailing conditions. So very easy to provide for a hydrogen infrastructure for ferries. Next in line are the coastal and inland waterway barges and cargo transporters, carriers of containers or bulk up and down the coast. Are the immediately next steps where we are already engaged in quite a lot of projects. Fishing vessels is on our agenda. We see a lot of interest from the fishing industry to go decarbonized into to have they simply improve their product, the fish, if caught in a carbon-friendly zero-emission way. They can up the prices on their fish. So we get a lot of interest from those. That's a challenging one, though, to work with. And finally, auxiliary load solutions for cruise ships and large ocean-going liners is also by now a common technical solution to assist larger ships that still have the combustion technology on board, but can supplement that with zero-emission power solutions for these cruise ships to enter into the precious heritage fjords and very sensitive nature areas for their cruising. The ships we have worked with so far are a range of vessels. For UK, maybe of interest is the High Seas 3 ferry, the demonstration of the hydrogen ferry for the Orkney Islands in Scotland. Here we are working with CMAL and University of St Andrews to prepare for a vessel for Orkney Islands. Also here Kongsberg in Norway is involved. The European Union has funded the Flagships project, which entails a passenger ferry in Norway and a river cargo carrier in France. We're working on the cruise ship solutions with ABB. In Germany, the German government is funding the Electra, a fuel cell hybrid system on a river barge going from Berlin to Hamburg. Then we have a couple of offshore supply vessels. That's another very interesting market for fuel cells, where we're working on one particular project with Ørsted, also very active in your area, I suppose. And the other one, SVACT, sort of having a coastal service set up, all being with a driver to go completely zero emission over time. In the US, we have done some of our first studies on tug designs, and we are slowly moving with lots of dialogue coming now also from Australia, of all places, to look into decarbonized solutions for ships. With this, I just want to thank you for your attention here. What we can offer you or customers you may know is to support you in the applications engineering phase. We can customize solutions for any customers regarding hydrogen and fuel cells and hybrid systems for installation. We can help you with the after-sales services, everything from maintenance, training, commissioning, approval processes will be also part of our services. Training is what we take particularly interest in, as David mentioned before on the buses, the importance to include all relevant stakeholders around a vessel into a training plan is of essence to make successful projects happening. And finally, on a sales and marketing and support side, we can also assist everybody. With this, I want to thank you. I hope I gave you a good insight also in the marine world, and we'll leave it back to Tony to take over from here.
Thank you very much, Kristina, for excellent presentation.